Hi everyone, and welcome to this video on revision for your National 5 Maths Winter FAB or Formal Assessment. Today we're going to look at some exam style questions for National 5 Maths, and basically the aim of today is mostly to practice, because that's what's going to get you the best revision. But hopefully by the end of the video you'll understand some of the skills required for the FAB and of course for the final exam. You'll be able to access exam style questions and link them to the correct topic and then being able to answer, of course, and then you'll know where the marks are allocated in each of the questions. So these are the topics that will be covered in the National 5 FAB for all National 5 courses, except if you're in a 2-year, the first of a 2-year higher, you will have covered all of National 5 Maths. So this video will still be relevant, it's just you guys will have covered a few more topics, and you'll find material for them on your Google Classrooms. So we're going to work through each of these 15 topics. I'm going to do a question of each one. And the way I would basically suggest we work this is I'm going to pop up a question on the topic. So here's question 1, which is on scientific notation. I would suggest you maybe pause the video, have a little go at it, and then I'm going to talk through the question, work through it, and show you the marking scheme at the end. And that way you've just got a chance to practice, and hopefully you'll be able to understand it by the end of each question. So here we go, question 1. Scientific notation and significant figures. The question says the mass of a helium atom is 6.64 times 10 to the minus 24 grams. A flask contains 300 grams of the helium. Calculate the number of helium atoms in this flask and give your answer in scientific notation correct to 3 significant figures. So this is a calculator question. Basically the crux of these questions is figuring out what the question is asking you to do. So here we've got a flask with 300 grams of helium, and each helium atom weighs this very small amount of grams here. So what we're basically being asked to do is to work out how many of these helium atoms is there in the flask. So the way we're going to do that is to say, okay, the 300 grams that we've got in total in the flask, we're going to split that up, or divide it, I guess, by the weight of each of the atoms. So 6.64 times 10 to the minus 24. You'll have to excuse my handwriting, it's not perfect on the iPad here, but hopefully you can see that and it makes sense. Then we're going to type that into our calculator to see what we get. You have to be able to type that into your calculator. So for me, I'm going to do 300 divided by 6.64, and I've got a button that says times 10 to the x or times 10 to the power of. You might have an E or an EXP button on your calculator, or you can just simply type in times 10 to the power of and then the power. But for me, I'm going to use the times 10 to the power of button. So type that calculation into a calculator and you will get 4.518 and so on. So 4.518 and so on and so forth, times 10 to the power of, and that's 25. So there's my answer, but what I need to remember is the question asked me to give it to 3 significant figures. So I'm going to have to round this. So 1 significant figure would be the 4, 2 significant figures would be the 5, the 3rd significant figure there is the 1, but we check what comes after the 1, which is an 8, which means that 1 before it has to round up to a 2. So 4.52 is my 3 significant figures times 10 to the power of 25, and that's it rounded and given in scientific notation. Calculator kindly did that for us. Okay. So here's the marking scheme. 1 for understanding the method, i.e. it's a divide calculation. 1 for evaluating, i.e. being able to type it into your calculator without the rounding, and then to give it to the 3 significant figures. And there are a few different extra notes at the bottom, just if you've answered it in a slightly different way. So 3 marks for that. Next question is an expanding brackets question. So these are fairly straightforward and routine questions, hopefully not something that cause you too much trouble. Have a pause of the video and have a go. Okay, and now we'll work through it. So I've got 2 things to do here. I multiply out this pair of brackets as well as this single bracket here. So we're just going to take them in turn. I'll start with the pair of brackets. So 6x times x is 6x squared. 6x times positive 3 is plus 18x. Then on to the minus 5. So minus 5 times x is minus 5x. Minus 5 times 3 is minus 15. And that's the pair of brackets done. Now on to the single bracket. So plus 2x times 4, so that's plus 8x. And then positive 2x times negative x is negative 2x squared. Now we've got like terms to gather in. I like to kind of give them an underline. So my x squareds, I've got a 6x squared and a minus 2x squared. So that's going to be 4x squared. Then onto the x's. So I've got plus 18x, minus 5x, and plus another 8x. So 18x take away 5x is 13x, plus 8x is 21x, so plus 21x. Then any numbers that are left over, so what have I got? I've only got a minus 15 here, I'll put a little box around that. Nothing to join together with that minus 15, so that's the only like term there. So that's expanded and simplified with all the like terms gathered. Let's have a look at the marking scheme. So you get 1 for starting the expansion, i.e. the double brackets or the single bracket, another 1 for completing, i.e. doing the other one that you didn't do the first time, and then 1 for collecting in the like terms successfully to get 4x squared plus 21x and minus 15. Question number 3. This one is a factorised question. So we've got actually two things combined here. We've got a little bit of algebraic fractions as well, which we'll come on to a little bit later. But let's start with the factorising question first of all. So part A says, factorise 4x squared minus 25. So there are three types of factorising: common factor, difference of two squares, and trinomials. Looking at this here, do we have a common factor? Well, no, because there's nothing that goes into 4x squared that also goes into 25. But we do have two squared terms, 4x squared being a squared term and 25 being a squared term, and a takeaway in the middle. So that's a difference of two squares. So we can go ahead and set up two brackets here. What do I need to square to get 4x squared? Well, 2 times 2 is 4, or 2 squared is 4, so 2. And obviously x times x is x squared. Sorry, that's a terrible x. I'll go back to this. Then what do we square to get 25? It's 5, so 5 times 5. 5's on the end. One bracket will be plus, and one bracket will be minus. Okay, so just for clarity, that first one says 2x plus 5, and that second bracket says 2x minus 5. And that's us factorise that. You only get 1 mark for that. Then part B says, hence simplify. So you'll notice that the top line, 4x squared minus 25, is the same as we've got in part A. So really all I'm asked to do here is, well, what did you do in part A and replace that here? Well, that's 2x add 5 and 2x minus 5. So let's go ahead and replace the top with that. The bottom line is 2x squared minus x and plus 10. So you need to spot that there's a bit of simplifying we can do there too. We can factorise that. That's a trinomial. 2x squared minus x and minus 10. 3 terms, an x squared, an x, and a number. So how do we factorise a trinomial? There are lots of different methods for this one. Particularly this one has a number in front of the x squared, i.e. not a 1x squared. So it's a bit more work to factorise something like that. You'll have a method for doing that. I'm just going to go right into, okay, it's 2x times x for 2x squared. And the numbers on the end need to multiply to make minus 10. So either 1 and 10 or 5 and 2. And when we're multiplying it out, the sum in the middle needs to come to minus 1. So I'll just do a bit of trial and error to say, okay, what do I think goes where? So 2 times 2 will give me 4. And 5 times 1 will give me 5. So 2x squared, 4x and 5x. And that's looking good. I probably want to minus the 5x. And plus the 2x to give me the positive 1. So I can always double check by multiplying it out. 2x times x is 2x squared. 2x times 2 is plus 4. Minus 5 times x is minus 1. And then, sorry, minus 5 times x is minus 5x, but add that to the one before, it's minus 1. And minus 5 times 2 is minus 10. So that was factorised successfully. If you're unsure about factorising something like that, if it's on a fraction, chances are it's probably going to match either one of these fractions on the top. So it's probably going to be one of the brackets is going to be 2x add 5 or 2x minus 5. So you could always have a little guess if you were unsure. What that's going to allow us to do now is to cancel off. You'll see I've got like terms on the top and the bottom. I've got a 2x minus 5 on the top and a 2x minus 5 on the bottom. So finally that'll simplify. It'll just leave me with 2x add 5 on the top and then x plus 2 on the bottom. And that's me. 3 marks. 1 for summing the top, the factorising, and then 1 for simplifying. A quick look at the marking scheme will tell you that. So part A was just to factorise, so there's the one step. Mark 1 for beginning to factorise that trinomial, finishing that factorising, and then the final mark for simplifying, i.e. crossing off the brackets. Let's have a look at what's next. So question 4 is an equations or inequations question. This one is an inequation, because you'll see it's not an equals, but in fact a greater than sign. So have a pause and have a wee go. Okay, let's begin to solve this. So when I'm solving an equation, I'm essentially trying to get all my x's on one side and the numbers on the other so that I've got a single x at the end. So we've got something to get rid of here. We've actually got some fractions to get rid of. Now again, there's a few ways to do this. Depending on what your preference is, you might decide to get rid of the 3, get rid of the 5, get rid of them together by doing the lowest common multiple. I like to do them separately normally. So I'm going to tackle these individually and I'm going to say, okay, I want to get rid of this first fraction here, the fraction of 3. So I'm going to times it by 3 to get rid of it. Anything that's not covered by that fraction also has to get times by 3. So I'll times that minus 2 by 3 and I'll times this final bracket by 3. Final fraction, sorry, by 3. So first one, timesing this by 3 is essentially going to cancel off the bottom of the fraction. So that's just going to leave me with x plus 1. So that's good. Minus 2 times 3 is going to make that minus 6. Is greater than, and in this one, when I times by 3, I'm not getting rid of the fraction, so I'm just making that one 3 times bigger. So 3x on the top gets 3 times bigger to 9x. So that becomes 9x over 5. One fraction is gone. Now I need to get rid of the other one. So I can do that now. I could gather in the like terms on the left. I'll just jump right to get rid of the fraction. So every individual term gets times by 5. So starting with the x times 5, that's going to be 5x. 1 times 5 is 5. Probably would have been easier to get rid of those like terms, but never mind. 6 times 5 is 30, so minus 30. And then now I've got rid of that fraction, so I've got is greater than 9x. Let's gather in our like terms. I've got 5 take away 30 on the left-hand side, so I can just join them together. 5 minus 30 is minus 25. So I've got 5x minus 25 is greater than 9x. Now let's get our x's on one side and our numbers on the other. So I want to get rid of probably that 5x on the left. Again, you could do it a couple of ways here, but I would say the easiest way here is to move that 5x from the left and onto the right, balancing out that equation. So take away 5x from both sides, and that's going to leave me with, sorry, I'm just going to jump up here, minus 25 on the left-hand side. And then on the right-hand side is greater than 9x take away 5x, which will be 4x. Trying to get this down to a single x, so next step is to divide by 4. So I'm going to have a fraction, minus 25 over 4 is greater than x. And that's a perfectly acceptable solution. Normally our x is on the left, so we can flip it round. But if you're going to do that, remember, you're going to keep the sign with pointing around the matching way. So x has got the pointy end, if you like, and the fraction's got the open end. So it stays like that, minus 25 over 4. And that's me. So 3 marks there. Let's have a look at the marking scheme and see where those marks were allocated. That's a bit fuzzy, that one, sorry. So 1 mark for eliminating the denominator, so that was me, I did that in 2 steps. You could do that in 1. Another mark for rearranging, so beginning to gather up your like terms, and then your final mark for dividing through to get just x on its own, and we've got negative 25 over 4. Question number 5 is changing the subject to the formula. So here we've got a formula, d equals the square root of 3h over 2, and we're changing it to h. So we're basically undoing the operations here. We're treating this just like we do an equation. So how do we get rid of the square that's on top of all this? We're going to, or the square root, sorry, we're going to square it to get rid of that. So you can write underneath to signify what you're doing. You can write SQ, you can put a wee power of 2, you can do what you like. So d is going to get squared on that side, so d squared. And then the squaring on this side is just going to get rid of that square root. We're doing the opposite operation. So that's 3h. That's a bit of a mess, that one. Fix that. So undo the square root is going to give me 3h over 2. Next thing I want to get rid of is the fraction of 2. So undo that fraction of 2. Well, how do I do that? Well, the opposite of dividing by 2 is timesing by 2. So we're going to times both sides by 2. So that's 2d squared here, and that's going to get rid of the fraction and leave me with 3h. Finally, I want to get h on its own, so I need to get rid of that 3. Well, that's 3 times h technically, so let's divide both sides by 3 to get rid of it. So this left-hand side is going to be 2d squared over 3 equals h. And finally, let's just swap the sides round to make it a bit proper. H on the left, and then everything else, 2d squared over 3 can go on the right, and that is the subject of my formula. 3 marks there. Let's have a look and see. So 1 for getting rid of the square, i.e. squaring both sides, 1 for multiplying both sides by 2, and then the last one for dividing by 3. So basically a mark for each operation. Question number 6 is a volume question. So this one is a composite shape. We've got 2 shapes here. We've got a cylinder on the bottom and a hemisphere on the top. And I need to work out the value of each one, or the volume of each one, and then combine them together to get the total volume of the shape. So you'll get given the formula for the volume of a sphere. It's 4/3 pi r cubed. This is a hemisphere though, or a half a sphere, so we want to make sure we're dividing that answer by 2. So let's stick in the values for the sphere. That's 4/3 times pi times the radius cubed. So what's the radius of the sphere? Well, it tells you the diameter of the cylinder, which is also the same as the diameter of the sphere, is 24. So the radius of it will just be 12. So it's going to be 4/3 times pi times 12 cubed. And then we're going to divide that answer by 2. And we can just stick that all in our calculator in 1. You might choose to break that up a little bit. But sticking it all into our calculator in 1, so 4 thirds times pi times 12 cubed, and then we want to divide our answer by 2. That's going to give me 3619.11. 3619.11. So that's the sphere, or the hemisphere. Now let's move on to the cylinder. So the volume of a cylinder, that's pi r squared h. Okay, so let's sub in our values here. Pi times the radius squared. Well, the radius is the same as what we did the last time, because they're the same radius. So it's 12 squared, times by the height. Now be careful with the height of the cylinder. They're giving us 70 as the height of the total shape. But I don't want the height of the total shape, I just want the height of the cylinder, so that only goes to about here. So what I'm wanting to say is, well, what's the height of the hemisphere? Because that's really the bit I want to get rid of. What's this bit here? I want to get rid of that. Well, that bit here is the same as the radius of the hemisphere, isn't it? Because that's the middle to the outside edge of the hemisphere. So that bit there, will be 12. That bit that I'm trying to get rid of. So the height of the cylinder on its own will be the 70, take away 12. So 70 take away 12 is 58. So the cylinder itself has a height of 58. So we're going to times by 58. Sorry, this is looking a bit messy. So let's stick that in our calculator. So pi times 12 squared times 58. And the volume of the cylinder is 26,238.58. So that's the cylinder. Now let's get the total volume of the shape. So the total, we're just going to add those two numbers together. So 3619.11 added to the 26,000, and we get 29,857. I'll write this down. 29,857.691, so on and so forth. Now the question did say, give your answer correct to 3 significant figures. We'll get a mark for doing that. So whatever answer you get, no matter you get it right or wrong, if you round it correctly to 3 sig figs, you've got a scope to pick up a mark. So let's make sure we do that. So the first significant figure is the 2. The second one is the 9. The third one is the 8. What comes after the 8 is a 5, so we're rounding up here. So it's 299, and the rest of the numbers can turn to 0. So the 5 turns to a 0, and the 7 turns to a 0, and we stop at the decimal point. Because if we put any numbers after the decimal point, they could be considered significant. So 29,000, sorry, and 900. We're talking volume here, so it's centimetres cubed. Okay, so let's have a quick look at the marking scheme. So volume of a sphere, subbing into the formula, and then obviously typing it all in and halving it. Volume of a cylinder, typing it all in and getting an answer. Adding the two together, i.e. combining the two volumes, and then rounding your final answer to your significant figures. Okay, next question. This one is an arcs and sectors question. So this question is asking us to give you some information, showing you a diagram. The radius of the circle is 20 and the angle in the centre is 45 degrees. Calculate the area of the sector. Take pi as 3.14. Now the reason it says that is that this is a non-calculator question. So we're going to have to work out the area of the sector, which means we need the formula for the area of a sector, or the sector area. So the formula for that is the angle at the centre over 360. That's the fraction of the circle that we've got here. Times by, and it's the area of a circle formula, which is pi r squared. If it was the arc length, it would be pi d. Now we can fill in the values. So what's the angle in the centre? Well, it's 45, so 45 over 360 times pi times the radius squared, and the radius is 20, so 20 squared. Now this is non-calculator, so we're not just going to jump to a calculator and stick that in. We've got a bit of work to do here. So 45 over 360 is a fraction that can be simplified. There are 8 45s in 360, so we can get that all the way down to 1/8. Times pi, which they told us to use 3.14, so we'll stick that in for 3.14. Times by 20 squared. Well, 20 squared is 20 times 20, that's 400. Now we've got to work this out. There's lots of obviously different ways you can do that. These are all multiplying, so you can do them in any order you like. I would usually suggest with this type of question, the easiest way to go about solving them is to take the fraction and multiply it by the number at the end. So start with the first and the last terms together. Because generally 1/8 of 400 is easier to do than 1/8 of 3.14 or any other decimal. So 1/8 of 400 just means 400 divided by 8. So 40 divided by 8 is 5, stick a 0 and makes it 50. So 1/8 of 400 is 50. There are 8 400s and 50. So all I've got to do now is multiply that by the 3.14. So that can be done in 2 steps, times by 10 and times by 5. So timesing it by 10, I suppose, would be 31.4. And that just leaves the timesing it by 5, which we can go ahead and write a wee sum for if we need to. 31.4 times by 5. 4 times 5 is 20. 5 times 1 is 5, add the 2 is 7. And 5 times 3 is 15. So it's 157. That's the area of a sector, so it's centimetres squared here. 157. Okay, let's take a look at the marking scheme. So 1 for getting the fraction, 1 for substituting the rest of the values into the formula, and then your final mark for the calculation. Okay, question number 8 is a surds and indices topic. So there are 2 questions here actually. Question number 1 is an indices question. So obviously there are lots of laws of indices and surds that you'll need to know. So I've just picked out a couple of examples here. So this one is a fractional indices question. We're asked to evaluate 9 to the power of 3/2. So you have to remember what that fractional power actually means or what it's asking you to do. The number on the bottom of that fraction, i.e. the 2 in this case, is telling you that that has to be our root. So this 9 has to be a 2 root or a square root. You could write a 2 there, but we tend not to do that because the square root is the lowest form, so we don't write that in there. So we just need a square root. So it's the square root of this 9, and the number on the top is the power. So root on the bottom, just like roots of trees are on the bottom, and power on the top, i.e. they get their power from above. So the square root of 9 to the power of 3. Evaluating that is just 2 steps. Well, it's easier to do the root first, that makes the number smaller. So the square root of 9 is 3. Now I've just got the cubed bit to do, so it's 3 cubed, which is 3 times 3 times 3, which is 27. Question number 2 is an indices question. It says, express root 2 over root 40 as a fraction with a rational denominator. So remember, a rational denominator means to get rid of the root on the bottom of the fraction. So I don't want that root 40 to be there. So the easiest way to do that, and the best way to pick up marks here, is to say, okay, to get rid of the root on the bottom, all we do is multiply by a special version of the number 1, I suppose, but it's the root that's on the bottom of the fraction. So times them by root 40 on the bottom, and also times them by root 40 on the top. What's that going to give me on top? Well, root 20 times root 40 on the top is root 80. And root 40 times root 40 on the bottom, what that does is cancels out the root essentially. 40 times 40, or 40 squared, and square root that will undo. So root 40 times root 40 is 40. If it was root 5 times root 5, you'd get 5. If it was root 7 times root 7, you would get 7, and so on and so forth. So that's me rationalise the denominator, but what I did say was to give my answer in its simplest form, so I'm going to have to simplify this as much as I can. So there's a bit of work to simplify the surds here, because I've got a root 80 which can be simplified. How do we know that? Because there's a square number that goes into 80. There's actually a few square numbers that go into 80. To make your simplifying easier, it's always best to choose the biggest square number that goes into 80. So what I would sometimes suggest is write out your square numbers, go, 1 times 1, that doesn't help, 2 times 2, 4, 3 times 3 is 9, 4 times 4 is 16, and go through and work out if those will all go into that number. For 80, the biggest square number that goes into 80 is 16. So what I'm actually swapping the root 80 for is root of 16, and it's 5 16s that make 80. So root 16 times root 5, or root 16 and root 5. Over the 40 on the bottom. Sorry, I'm squeezing this in here. Square root of 16 is 4, so that comes out of the root now as 4. Root 5 we can't simplify, so it stays as it is. So root 80 simplifies to 4 root 5 over 40. And then hopefully it's easy to see, you've got a number on the top and on the bottom, both that are divisible by 4. 4 divided by 4 on top is 1, so you just get 1 root 5, or root 5. And on the bottom, 40 divided by 4 is 10. So you get root 5 over 10, and that's it. It's fully simplified as it can be. Let's have a quick look at the marking scheme. First one was only worth 2 marks. It's for into the form, so the square root and the power of 3, and then for processing that to get 27. And then the second one, a couple of different methods you can go about. As I mentioned, the first method here is the method that I have used, so times the top and the bottom by the root 40, and then simplify from there to get 5 over root 5 over 10. Question number 9 is an algebraic fractions question. So it says express 7 over x minus 3, take away 2 over x as a fraction in its simplest form. This bit here you can kind of ignore really at this point. It's really just a bit of mathematical format saying that the fractions on the bottom can't be equal to 0 because we can't mathematically divide by 0, but you can basically ignore that. So it's asking us to take these two fractions away from each other. So I need a common denominator. Easiest way to do that is to multiply these two terms together. So x times x minus 3. Doesn't really matter the order you do it. I suppose this is just a neater way of having it. So x times the x minus 3 or x minus 3 times x on the bottom. So what does that mean? That means this fraction on the left has been multiplied by x. Sometimes you might consider that as kissing the smile. So I'm having to multiply that x also by that 7. So that's going to give me 7x. Take away, this one on the left, or the right, sorry, has been multiplied by x minus 3. So that 2 on the top also has to get multiplied by x minus 3. So there's the kiss bit. So 2 has to multiply by x minus 3. And I think it's important to write that step in. Instead of just going 2 times x is 2x and 2 times minus 3 is minus 6. Because what you'll notice is this is a minus 2 here. And what I'm going to do when I multiply out the bracket is going to end up meaning I've got a plus 6. So I think it's important to write that step out. Now we can multiply out the bracket and begin to tidy up. So 7x minus 2 times x is minus 2x. And then minus 2 times minus 3 is plus 6. So you notice how that didn't work out as minus 6. On the bottom, x times x minus 3, you don't actually get any marks for multiplying that out, so we can leave it as it is. But we do need to tidy up that top bit because we've got some like terms. 7x take away 2x, which is 5x. Plus that 6 over the x bracket x minus 3. Sorry, squeezing that in there. And that's it, fully simplified. Quick look at the marking scheme. So common denominator, that was our multiplying the terms together. Then the numerator. And then for collecting the like terms and simplifying it as much as you can. Okay, question 10 is a straight line question. So there are lots of different ways we can ask a straight line question. Quite often they're given in a context. Sometimes the coordinates are just written. This one has a wee diagram, but really we've just been given two coordinates and asked to find the equation of the line that joins those 2 points. So because there's no context, it's just an x and a y axis, this is really just a straightforward straight line question. So what do I need to get the equation of a straight line? Well, I need the gradient of the line. That comes from the formula y2 minus y1 over x2 minus x1, a formula you're not given, so you have to remember it. Here's x1 and y1. Here's x2 and y2. Doesn't matter the order you do that in. This first one could be 0.2 if you like. So for me, y2 take away y1 is minus 2, take away 6. And x2 take away x1 is 3, take away negative 1. So minus 2 take away 6 is minus 8. And 3 minus minus 1 is 4. So minus minus makes a plus. Minus 8 divided by 4 is minus 2. So that's me got the gradient of the line. Now that I've got the gradient, I want to go ahead and stick that in for the equation of a straight line, which is y minus b equals m brackets x minus a. So m is my gradient. I need an a and a b though, so I just need to choose one of the coordinates. Doesn't really matter which one. I'll choose this one. So a is minus 1 and b is 6. Substitute them in. Y minus b is y take away 6 equals m, which is my gradient, that's minus 2, bracket x minus a, x minus minus 1. The two minuses will make a plus, so I'm just going to go ahead and make that x plus 1. So just be careful with your signs there. You might want to write x minus minus 1 before you tidy that up. And then lastly, let's multiply out the brackets and tidy that up. So when you multiply out the brackets, you'll get minus 2x. Minus 2 times 1 will be minus 2. And I'm going to move that minus 6 on the left-hand side over, sorry, just because I'm running out of space. I'm going to make that plus 6. So altogether, y equals minus 2x, minus 2 add 6 makes plus 4. So I get y equals minus 2x and plus 4. So I can see in that format, the gradient is minus 2 as we worked out, and the y-intercept would be at 4. It's not part of this question, but we could be asked to identify the y-intercept from that format. Okay, so a quick look at the marking scheme, and that's the equation of the straight line and the x and y. If it was a context question, it would maybe be different letters. We'd have to consider the context of the question, but here we don't. So, 1 for finding the gradient. Not something they haven't simplified it here, but just to get into negative 8 over 4. 1 for substituting one of the points and that gradient into the equation of a straight line, and then for simplifying it. So y equals negative 2x plus 4. Next question. Question 11 is a simultaneous equations question. So again, there's lots of different ways this could be asked. Generally, it could be a context question, so something like I went to the shop and bought 3 apples and 2 bananas and it cost me £5.70, and then next day I bought 2 apples and 6 bananas and it cost me £5.40, and work out the cost of an apple and a banana. You would generally recognise those types of questions as simultaneous equations. This one is similar, but except it doesn't have a context, so I'm just looking for a value for x and y. It could also be the intersection of two straight lines, because really 3x add 2y equals 17 is the equation of a straight line, so is 2x add 5y equals 4. So what we're finding when we solve this is the intersection between those two straight lines. So look out for that as part of a context as well. So let's go ahead and solve these. The way to solve simultaneous equations is to make either the x's or the y's match first of all. So I don't have either of the terms matching, so I'm going to go ahead and make the x's match, which means I need to times this top one by 2 and this bottom equation by 3. So that's going to give me 3x times 2 is 6x, 2y times 2 is 4y, and 17 times 2 is 34. Bottom one, 2x times 3 is 6x, 5y times 3 is plus 15y, and then 4 times 3 is 12. Now that I've done that, the x's are matching, so I can go ahead and eliminate them. That means either adding them together or taking them away. So the key thing is to look, what am I trying to eliminate? They're both positive 6x. The way to eliminate them is to take away. So 6x take away 6x from top to bottom makes 0. It's gone. That's the whole point. 4y take away the positive 15y. So 4y take away 15y, if you like, is negative 11y. 34 take away 12 is 22. So negative 11y is equal to 22. Well, I just want y though, so I'm going to divide both sides by that negative 11. So y will be equal to 22 divided by negative 11, which is negative 2. So now that I know that y is negative 2, that's one of the values, I need the other one. So I'm going to go ahead and substitute that y into either one of the equations. It doesn't matter which one you choose to substitute it into. It could be the first one or the second one. I'll just go with the first one. So the first one says 3x plus 2y's. So now I know y is minus 2. So I'm going to swap y for minus 2. And it tells us that is equal to 17. So 3x, 2 times negative 2 is minus 4. So 3x take away 4 is 17. Solve this equation now. Add 4 to both sides. So adding 4 there makes it go away. 17 add 4 is 21. Divide both sides by 3 and get x is equal to 7. So there's my two values. If it was a context question, you know, the cost of an apple and a banana, you would want it at the very end, right? One apple costs you £1.50, one banana costs you 80 pence, or whatever the question context was about. But this one just was asking us for an x and a y value, so that's us solved it. You might choose to just summarise it at the end. Let's have a look at the marking scheme. So one for scaling your equations, i.e. making something match, the sixes, just like I did. Then a strategy for finding either the x or the y value, so I eliminated to find y first, and then a final mark for stating both correct values. Question 12 is a vectors question. This one is a fairly straightforward one, so there's lots of things we could do with vectors. It could be a 3D coordinate question, it could be a vectors pathway question, we could add or subtract vectors. But here I've just been asked to calculate the magnitude of a simple vector. So no work before it, no scaling any vectors or adding or subtracting, just to simply find the magnitude of this vector. So how do I find the magnitude of a vector? Well, the magnitude of a vector is the vector's size, and basically it's a version of Pythagoras we use to find the length or the size of a vector. So the magnitude of d, that's what these two lines represent, a line either side of the letter d. The magnitude of this vector is the square root of each of the terms squared and added together. So 1 squared plus negative 4 squared plus 8 squared. Okay, so let's work that out. 1 squared is 1. Negative 4 squared, remember a negative times a negative is a positive, so that's 16. And 8 squared is 64. So add them all together. 16 add 64 is 80, add 1 is 81. Square root of 81 nicely works out as 9. So that one can be done without a calculator. Not always the case, but this one can be done without a calculator. Let's have a look at the marking scheme. So one for starting the process, I would probably suggest you should have a square root over the top of there, and then the second one for just working out the answer. So nice straightforward vectors question. Question number 13. So this one is a similarity question. You kind of can tell that just from the two similar shapes, and it literally says in the question, the two photographs shown are mathematically similar. So let's read the question a little bit. Oops, that's the marking scheme I've just showed you. There we go. Right, let's have a look at the question. So the small photograph has an area of 80 square centimetres. So we know that this one is 80 centimetres squared. I might write that one. That's 12 centimetres wide. We've got that in the diagram. The large photograph has an area of 500 centimetres squared. Calculate the width of the large photograph. So the width here, maybe I'll call that x, is the bit I'm trying to find. Now this is a bit of a backwards working similarity question, this one, in that we are being given both the volumes. Quite often, normally, typically you would see in these questions that you would be given both the measurements and asked to work out the missing area in this case. So we have to do a little bit of thinking here. Well, we know that our linear scale factor normally is the new over the old. But here we're not going to be able to get a linear scale factor straight away because the linear values, I'm missing one of them, this width x. So actually I want the area scale factor to start with. Because I can do that, the new over the old. Well, the new one is the one with the something missing, it's the one with the x on it, so this is the new shape. I'm looking for a bigger measurement, so I want a number that's going to make it bigger. So 500 over the 80 is my area scale factor. So how would I turn that back into the linear scale factor? Well, we know the area scale factor is the linear scale factor squared. So I kind of want to undo the squared. So to undo the squared, to get back to the linear scale factor, I'm going to do the opposite of squaring, which is the square root. So the linear scale factor here is the square root of 500 over 80. So I can type that into a calculator just to get a value, or I can go ahead and just use that in my calculation, because this is a calculator question. So to work out x, it's going to be the 12 centimetres from the small photograph multiplied by the linear scale factor, which is our square root over of 500 over 80. Maybe I'll just work out what that is. So the square root of 500 over 80 is 5 over 2. So it comes out to 5 over 2. Multiply that together, so half of 12 is 6, times by 5 is 30. You take that into a calculator. So 30, and it's a linear measurement, so it's 30 centimetres in this case. Okay, so quite a tricky one. We had to think a little bit carefully. Normally it's you've got the linear scale factor and work out the area scale factor to find a missing area. But here we had to work a little bit backwards. Okay, so hopefully that made sense. But let's have a little look at the marking scheme. So the area scale factor was the 500 over 80. Another mark, your second mark there for basically starting that next calculation. It includes the square root and the multiply by 12. And the final one for working out your answer of 30. Okay, question 14 is a functions question. Nice topic, functions. This one is split up into two parts. So we've got part A is just to evaluate f of minus 4. So what does that mean? Well, that means take this function f of x and swap the x for a minus 4. So minus 4 instead of x squared plus 3. What's minus 4 squared? Be careful if you're typing that into a calculator ever. Make sure you put that minus 4 in brackets, or we could do that ourselves without a calculator. Minus 4 squared is positive 16. Plus 3 gives me 19. So the value of that function at when x is negative 4 is 19. Part B says find t when f of t equals 52. So what's happened here? Well, first of all, they swapped the letter x for the letter t. So let's rewrite out the function again. But instead of f of x, we'll call it f of t. So instead of x squared, it's t squared plus 3. Then they've told us that that function is equal to 52. So this is working a little bit backwards. That's saying what number did I put into that function to generate the value of 52. So t squared plus 3, putting some number into that equals 52. And our job is to work out what that number must be. So it's solving a little equation. Take away 3 and take away 3 from both sides. Gives me t squared is equal to 49. And then square root of both sides will give you t. The square root of 49, which we know is 7. So it must be 7 that goes into that function to produce the value of 52. Okay, so a bit of backwards working with functions. And a wee trick there in that we swapped a letter. But nice and straightforward. So marking scheme, this is quite an old question, so it looks a little bit different to the marking schemes that we see nowadays. But basically one for substituting into the function to start with and then getting your evaluation or working out 19. And then for the second one, making it equal to 52, and then solving that process. It does say plus or minus 7 there. I should have said that the square root of 49 can be positive or negative 7. So it's just highlighting the fact that that could be the case here. Question 15, and the last topic we're going to look at is trigonometry. So we could be solving trig equations. In this case here, we've got actually a trig graph combined in with a trig equation question, is why I picked it. So first of all, let's have a quick look at the trig graph. And it does tell us the equation of the trig graph, but we should be able to recognise it. So it tells us that we've got the graph of y equals 3 cos x minus 1. What would that mean? Well, the 3 in front of the cos is the amplitude, so that means it goes up 3 and down 3. You can tell that between the distance between 2 and minus 4 is 6, and half of that is 3. So that's how we know the amplitude must be 3. It also says it's got the whole graph has been shifted down by 1. It's got a minus 1 on the end. So a 3 cos x graph should go to a maximum of 3, but this one goes to a maximum of 2, so that means down 1, hence the minus 1, and its minimum should be minus 3. It's not working in there. Minimum should be minus 3, but it's moved down 1 to minus 4. Just thought I would highlight that. Not part of this question here, but that's where that graph comes from. You could get asked a question on identifying a trig graph. So, this question though, we've been given the graph, told the function, and it says calculate the coordinates of the points where the graph cuts the x-axis. So that's here and here. So what does that mean? Well, that means I'm on the x-axis, therefore the y value on the x-axis must be 0. So the y value here is 0. So actually we're just making this equation, 3 cos x minus 1 equal to 0. That's probably the hardest part of that, because once we've done that, it's just a case of, well, let's just solve this for x. So how do we do that? Well, we add 1 to both sides first of all. That'll give me 3 cos x equals 1. Then divide both sides by the 3. Will give me cos x equals 1 over 3. Now, I can get a related angle from that. Remember, your related angle should always be the positive value, so if that was a negative, I would need to turn it positive. So inverse cos of that 1 over 3 is going to give me the related angle. So shift cos, so in your calculator, you need to find the inverse cos function of 1 over 3, which is 70.528. So I'll just call that 70.5. So that's my related angle. Now I need to work out where my solutions are actually coming from, and we've got a diagram that helps us do that. It's the cast diagram. So where are my solutions coming from here? Well, I was solving for cos x equals positive 1/3. So that meant cos was a positive function or a positive value. So cos is positive here between 0 and 90 in the all quadrant, and cos is positive here between 270 and 360 in the cosine quadrant. So each of those has an operation. Well, the first one doesn't. It's the related angle. It's the one the calculator gives us. And in the final quadrant there, this one is 360 minus the related angle. So to get my two answers for x, or my two values for x, first one is my related angle. I've already got that. It's 70.5. Second one comes from 360 minus that 70.5, which is 289.5. Now those are the two x values. Normally when you're solving a trig equation, that would be fine. But this one did say, never mind, it says calculate the x coordinates. We're absolutely fine. I thought it said coordinates, but it's only the x coordinates after. So we're done. 70.5, that must be this one here. And then 289.5, that must be that one there. So let's have a look at the marking scheme. Oops. So one for forming the equation, like I said, that's often the trickiest part if it's not given to you straight away. So here we had to work out to set it equal to 0, then begin to solve. Find one value, so that was a related angle, in this case 70.5, and then for finding the second value, that's your cast diagram part. So 4 marks there for solving that trig equation. And that is our last question. Hopefully you found that useful. Some suggestions for what you could do to aid your revision over the holiday period. You've obviously got SQA past papers available to you on the SQA website, or this really good website, Free National 5 Maths, which most of you will have had highlighted to you already at some point. If you just Google Free National 5 Maths, there's lots of good resources, basically past papers split up into topics or as whole, and lots of other mixed resources which are useful. On YouTube, you'll find talk through a lot of the past paper questions. We have our own section, Algebraic Mathematics, which talks through lots of the topics. Or there's a guy, DLB Maths, that talks through each of the previous past papers and does a really good job. So if you're stuck on a past paper question, it might be useful to just search it on YouTube. And then on Google Classroom, you'll have your evaluations from each of your block assessments. So that'll tell you some of the areas of strength and things that you might want to work on. And you also have notes and questions and any other revision material that's been provided to you by your class teacher. So hopefully you found that helpful. Best of luck with your revision over the holidays. I hope you also have a nice, relaxing and enjoyable holiday, and then we'll see you guys back in January for those formal assessments.